Okay, continuing on to problem number 2. It says Mr. Dodson is having the exterior of his house painted. The painters charge $35 per hour plus the cost of materials. After 20 hours of work, Mr. Dodson owes the painters $840. So this is perfect. They're telling us that $35 per hour, so that's our rate of change, is 35 per hour. Our slope is going to be 35 over 1. That's our rate of change. It also tells us that at 20 hours, we owe $840. So this is, in fact, a data point. And so then we go straight to writing an equation. Y minus 840 is equal to 35 times x minus 20. Let me give myself a little bit more room here. These numbers are a little big. So y minus 840 is equal to 35 x minus 20 times 35 is 700. So then we're going to add the 840, and we get y equals 35x plus 140. So it's $140 for the initial value. Excuse me, painter's charge plus the cost of materials. So it's $35 per hour for labor plus $140. So the $140 is the cost of the materials. You know, the paint, the tape, the rollers, whatever. Okay, so this is your answer here. It's $35 for rate of change and $140 initial value, which covers the cost of materials, according to the story problem. All right, number 3. Before a movie began, a theater had people waiting in the seats. During each of 4 movie trailers, 7 more people came into the theater. When the movie started, 82 people were in the theater. Assume the relationship is linear. Find and interpret the rate of change and the initial value. Okay, so during each of 4 movies, 7 more people came into the theater. When the movie started, 82 people were in the theater. When the movie started, 82 people were in the theater. So, okay. So, if the movie when the movie starts, time is at 0, and there are no when the movie started. So basically, okay, so you go through a trailer, right? You watch the trailers, and then the movie starts. Okay. So during each of 4 movie trailers, 7 more people came into the theater. So basically what happened is we had 4 trailers. Wow, is this one confusing? The way that it's written. During each of 4 movie trailers, 7 more people came into the theater. So I would say after the 4 so what I'm thinking is this, so that you see my thought process, because that's what's important here, is that you guys follow the thought process of somebody who knows what they're supposed to be doing. So okay, so the idea is that at time is 0, there's the y-intercept number of people. Okay, and then the first movie trailer comes in, and there's b plus 7, and then at the second trailer, you get b plus 7 plus another 7, right? And on the third, you have however many people you started with, plus 3 times that 7, because now you're just going to add another one. And then after the fourth movie theater, or after the fourth, you have B plus 4 times 7. And they're saying that this number here is equal to 82 people, is what I'm getting out of what they're saying. So, okay. And they want to know what this number is right here, right? So that means that B plus 28 has to equal the 82. So if we subtract 28 from both sides, we get B is equal to 12. That's a 4. 7 minus 2 is 5. So there were 54 people before the movie trailer started, right here. And then they added 7 people each time until they got to 82. That makes sense. And so our rate of change is 7, because this number keeps going up 7 each time, and this number is going up 1 each time. So our equation would be y equals 7x plus 54 in this situation. And if that didn't make sense, we'll talk about it some more. Let me know, and we'll talk about it in class. Problem number 4. The art club collected $15 from each of its 17 members for dues. It then had $300 in its account. So if you collect $15 from each, that's $15 per member. From each, yeah, $15 from each of its 17 members. It then had $300 in its account. So the per is 15. So y is equal to 15x plus whatever. Now what they're doing is they're saying that they had $300 after the 15 members donated money or paid their dues. So they had 17 people pay $15 each. And at the end of that time, they had $300 in the account. All right, I'm switching gear. I'm changing my method here, and I don't want to do this. Let's go back. Let me go back to doing it the way I was showing you earlier, because I don't want to mess you up. So it says it's $15 per member. So that's going to be our slope. Is going to be 15. And then we have a data point at 17 members being 300 balance. So what we want to do is we want to do y minus 300 equals 15 times x minus 17. And so we get y minus 300 equals 15x minus 15 times 17. Let me get out my calculator. $15 times 17 is 255. And so then we're going to add 300 to both sides. And you get y equals 15x plus 45. So it says find and interpret the rate of change and the initial value is the question in problem number 4. The $15 is how much each member is paying as dues. And the $45 is the initial starting value. And from the looks of it, because 45 is divisible evenly by 15, it looks like 3 people already paid their dues. And that's where they got the $45 from. And then they collected another 17 dues. So far, it looks like they have 20 people in their club and maybe more. Who knows? The other people haven't paid their dues yet. Number 5. The population of DeSoto rose at an average of 142 people for each of 5 years. It then had 5,428 people. Assume the relationship is linear. Find and interpret the rate of change and the initial value. Okay, so the population of DeSoto rose an average of 142 people for each of 5 years. So that's our rate of change, 142 people per year for each of 5 years. That's just a fancy way of saying it. It then had 5,428 people. So this creates a data point. It creates a snapshot in time that after 5 years you had that number. And this is our per. So this is our x, this is our y, this is our per, our slope. So we're going to do y minus 5,428 is going to equal our slope of 142 people times x minus 5 from the equation, and then we just solve for y. If I could write it, that'd be dangerous. So y minus 5,428 equals 142x minus 5 times 142 is 710. So we add 5,428 and we get y equals 142x plus 5, 4, no. And we get 4,718 people were in the city before 142 people moved in each year for 5 years. Okay. And problem number 6. It says Ling starts out with a certain number of baseball cards and plans to collect 8 each month, which would be 8 per month. At the end of a year, he has 109 baseball cards. So this is a snapshot in time. And at the end of a year, haven't we gone 12 months? And the reason we want to make that, we want to notice that that's 12 months because they're saying their slope in months. Assume the relationship is linear. Find and interpret the rate of change and the initial value. So again, we just go back to our standard formula. This is the point slope formula because we're using the slope and a point. So this is the point, x and y, and this is the slope. And that's why we call it the point slope formula, to find out what we need to know. So we're going to do, and the way that we plug into this is we plug in 109 cards, because this is the snapshot in time, 12,109, with our slope equaling 8. So we get 8 times x minus 12. So y minus 109 is equal to 8x minus 96. We then add 109. And so y equals 8x. What is that? Plus 13. So this person is adding 8 cards a month to his collection, and at the beginning of the year he started with 13 in his collection. And that is the end of this second video. Have a great day.